Now, it rained a little bit, so it cooled down the weather. Therefore, let's, with a really warm round of applause, welcome Woody to the stage, please. Woody, the stage is all yours.
Thank you. Very, very happy to be here. It's my first time talking in Budapest, and thanks to the organizers and to the sponsor who made this event possible. I hope for better weather, but I'll adapt. I'm going indeed to be talking about API and event-driven architectures, but by show of hand, first, who would describe themselves as an API-first person in the room? Not a lot. And event-first? A bit more, but a few people are neither, so I'm wondering which approach you'd prefer. But I'm going to try today to reconcile the conflict I've witnessed a lot between API fans and events fans. I've witnessed a lot of fights around this topic between CTOs and CIOs who have a very strict approach to pick between one or the other. And usually what I hear from API fans is that event fans over-engineer stuff, stuff that should be simple become very complex. I'll go more into the trade-offs of two approaches later, but that's usually what I hear. And events fans usually say that API fans live in the past, and that if you want to build something that is real-time and that is where stuff happens in an invisible fashion and is resilient, you can't do it strictly with APIs. So my target today is going to be try to bring these two people together and make them love each other again through an approach that I'm going to describe. So a few words about me. I'm Woody. I'm the CTO and co-founder of the fintech practice of Theodore Group. So we're a consultancy. We're a tech consultancy based in France mostly, but in the UK, the US, and Morocco. And so we design and we code and run apps, especially in the fintech space. And because of it, I'm a big API fan. I would describe myself more of an API fan as an event fan. I've talked a lot at API Days. And one of the reasons is that APIs are very important in the fintech space because of open banking, the idea that banks should expose data through APIs rather than having closed financial service systems. But recently, I've realized that something was probably missing to achieve the mission that we're trying to do at my company, which is to try and make finance invisible and real-time. And so this was the idea of managing real-time transaction between several systems. And I felt like a piece was missing when I was only looking at the API aspect. So I got really interested in the event side of things. And in the talk today, I'm going to first try and describe the use cases and benefits of each approach. I'm going to go a bit fast on that because I think most of you know about those. I'm going to talk about the trade-offs, which I think are going to be more interesting. When you pick one approach or the other, what are usual problems that you're going to face and stuff on which you might have challenges. And then I will introduce a concept that we've battle-tested on large projects with a lot of different teams with a very big architecture with 40 deployments in production per day, which has both approaches, and that's what I'll be calling API first, event always architectures, and hopefully this will be useful to you guys. So to begin with the use cases and benefits, and I'll begin with APIs. So APIs, as was described here in the room, is very well suited when you have one-to-one synchronous communication. And I think the best example would be a phone call. So you call someone, you expect an answer, and either the person doesn't answer because he's busy, he has too much work to do, or he answers your request. So this is very good for that, and events will have a different benefit. The second big benefit of APIs is that they're very easy to monitor, and observability for me is easier in the API stack because, for instance, if a client uses a web app which uses APIs, if it fails, you'll know about it because the client will call you because he'll have an error on the screen, which is not always the case with events. It's sometimes trickier to figure out that something went wrong. So this is very good for monitoring and figuring out incidents and defects. And finally, the third I feel benefit of the API-first approach is that tooling is, in my opinion, more advanced. One of the reasons being that APIs evolve from service-oriented architecture, which are a bit older. And because of that, you got a lot of different tools that are useful. On the server side, obviously, you have OpenAPI, which has really standardized viewing and browsing an API contract. Very recently, it was announced, I think last week, there's even a Rousseau, which is a way to specify API workflows. You should check it out if you haven't still. The idea is to say that the documentation of single endpoints and entities is not enough, and that usually developers need to call a series of different endpoints, and Rousseau aims at doing that. Hopefully this will end up generating documentation and sequence diagrams on developer portals. You have developer portals, one example being FPG, but there are a lot of others, such as Backstage, which was open sourced by Spotify, and the idea is that you can easily view and browse API contracts. So you got a lot of great tools on the server side. But you also have great tools on the client side, which is the component that consumes an API. You have, with OpenAPI Generator, for instance, a way to generate API clients. So this is very good for, I've seen a lot of defects in projects we've done where you have a mismatch of types between the client and the backends. For instance, you will generate your OpenAPI contract, but then you will create, for instance, in TypeScript interfaces, and sometimes they don't match. So using a tool like OpenAPI Generator allows you to always have aligned the DTOs on the backend and the client interface. And finally, you have a lot of different libraries. For instance, in Java, you have Resilience4j that allows you to build in resiliency, such as retries, circuit breakers, and stuff like that, that allow you to have more resilient architectures around APIs. So we've got a lot of tools, and this is, for me, a big benefit of the API ecosystem, which is why usually teams are more versed into using APIs and will prefer to use it, in my opinion. But events also have a lot of important benefits. First of all, events are usually used for one-to-many asynchronous communication. So I spoke of the telephone metaphor. If I was to do a similar thing here, I would think of a mailbox. For instance, you send a message to someone. The letter ends up in the mailbox, which is not in the house of the person you want to reach. It's outside, and the person can go fetch it whenever he wants. So you have this middleman, which is a queue or a topic, where you will send messages that your consumers can consume at any time, and you can have several consumers take the event and do various things. So this is the first benefit, and this is more like the use case of using APIs, events, sorry. Another benefit is that they make things scalable. So for instance, if you got the queue that gets filled up with a lot of messages, you can just choose to add in more consumer components to process the events at a faster pace. And that is good because when you have APIs on an app that tends to have scalability that evolves at a very fast pace, sometimes even if you use Kubernetes with auto-scaling, sometimes you don't have the time to catch up with the volume that you have. Well, with events, you'll just have some clients waiting or some events to be processed at a lower pace. And so when new pods do scale up, you will end up manage to get the events without having any error. So this is good for scalability. And the third benefit would be fighting the curse of coupling, which is especially present in microservice architectures. The idea is that you have a middleman, so technically the producer and the consumer are not coupled. I feel like this benefit is a bit is not well understood because in a way you still have coupling because obviously the message that you send does have a specific format, and if you change it, you will have breaking changes and the consumer components will not be able to process it. So I wouldn't say that event-driven architectures are decoupled, but we usually say they're loosely coupled, which is a better term. You have a way and strategies to have these architectures evolve in a less risky way than API-driven architectures. So what are the trade-offs of the two approaches? So there are no free lunches. Obviously, each approach has trade-off, and you're guessing it, but at the end, I'm going to say that it depends, and you need to use one in certain situation and the other in other situations. But I've seen a few trade-offs. And if I want to start with API, the first trade-off that I've seen a lot is what I call API frenzy. And so this is actually a quote from not Patrick Bateman from American Psycho, but from a bank CIO who said to me very proudly, I have 10,000 APIs in my information system. And he was very proud of that. And what he didn't know is that I had access to the catalog of APIs, and they were absolutely awful. You couldn't use them at all. I mean, having APIs is a way for a CIO to create reuse and to have a development team reuse code rather than recode them. But when I search, for instance, for risk, because usually in a bank you need to assess the risk of a fund portfolio, I found tens of different results, none of which were documented in any way. I had no idea which one to use, and I couldn't use them at all. And the reason was that the CIO had forced development teams to expose their APIs in a catalog for them to use them for their product and for their user stories, but he didn't take care of how do you maintain quality when you create an API rather than quantity. So this is a big trade-off that I've seen. Second trade-off, I would call this API chains, and this is something I've seen a lot in microservice architecture. So you have a very simple user story. I want to see the user's birthday, and somehow you end up having to call 10 different microservices to get this very simple information. There is a very funny video. I don't know if you know this channel, which is called CraftHub, and they've done a lot of very funny video, but especially one which is called Microservices, which illustrates well this concept of a PM wanting something very simple and figure out that it can't be done before the end of the year because of microservices. So watch it if you want to have some fun. There are a lot of other videos that illustrate this really well. And the third trade-off, I was less inspired, so I just call this API crap. And the idea is to say that you have sometimes API where you can see in the response that it was built for a very specific UI or a very specific user story, so you can't reuse it at all. And so for instance here, this would be an endpoint to get the balance of an account. If you have HTML in the response, probably you won't be able to use that information if you do a mobile application. And I've seen this a lot in different projects. What about events? So you have different trade-offs for events, and the first one I would call this event immaturity. And for me, it's a bit the same as microservices. When your organization is not mature enough, you will end up having a lot of problems if you want to adopt events. Because a lot of things that were simple with APIs become complex with events. For instance, what happens if something fails, where you have to have what is called a dead letter queue, and you have a team that looks at dead letter queue to handle failures, while in API approach you have an error, so you're forced to treat it. And you have more complex scenarios. For instance, if you have an event which requires 3 different actions from 3 different components, what happens if 2 of them succeed and 1 fails? Do you have to roll back the actions that the other consumers took? So those are questions that development teams need to ask themselves. Product managers are not going to be good at thinking about these situations. So usually, technical conception, technical design become more complex. You have a lot of edge cases that you need to think about that you didn't have to in API approach. So you need more training, you need more tooling to be able to do that. The second trade-off, I would call it event paralysis, and I mentioned that when I talked about coupling, is that it's very difficult when you need to have your event evolve its schema. So for instance, you have a name field that changes its name, and you can't figure it out, you can't make it in a non-breaking way. It's very difficult because you need all your different consumers to migrate to this new event schema. And sometimes it's easy because it's an added field, but sometimes you need to remove something, and so it's very hard. So we'll talk about this in the tricks we found to manage this situation later. And the third trade-off, I would call it event obsession. I've seen a few CTOs and CIOs who only want to use events, even for very simple things. You want to fetch an information, and you are going to ask a service to send a message to another one and get it through WebSocket or server-side event, and it becomes very hard. So I've had ChatGPT generate a C4 diagram of a to-do app using only events. So you can see the complexity that you can get if you really want to have an event-only approach. So what are the different secret sauces that we found to work in order to mitigate the trade-offs and also to figure out in which cases you want to pick APIs and in which case you want to use events? So for APIs, I've described 3 trade-offs. You have poor API designs, who are usually coupled with UI needs. You sometimes have very large chains of APIs that deteriorate performance, because what I didn't mention as a trade-off when we saw the diagram with a lot of microservices is that each arrow adds network latency, and so you can end up having poor performance just because of that aspect. And third of all, the API number as a vanity metric that I've seen in banks. And so for me, There's one big remedy, which is kind of obvious, but I've called this Stripe level quality, because Stripe for me is really the player who've introduced a lot of theory around what a good API is, rather than making a lot of APIs. And so we've built a few key points that teams can use in-house to check if their API is good or not, and it will bring value to the organization. The first two key points, the first one is evolutiveness. And the idea of evolutiveness is that you have very good processes and tools to maintain backward compatibility, so you will avoid breaking changes. And if you do breaking changes, you will provide very good documentation for teams to migrate to new versions. And you can keep this backward compatibility while making it feature-rich, and you can bring innovation at a fast pace. And it's a difficult trade-off to achieve, but evolutiveness is the first aspect. And the second one is composable. And the idea of composability is that when an organization such as Stripe provides several services, you want to make sure APIs work well together. And you don't want to have, for instance, if you provide several services that need identity verification, it's probably not a good idea to have different identity verification endpoint in each API. You need to figure out that you need to provide an identity verification API, and then to provide the different services that you have. And for me, these two aspects are really well handled by domain-driven design, which is for me a very big prerequisite of having good APIs. So for instance, if you do event stormings, you have a good way to discover the domain through aggregates and events. And although this won't always make you avoid backward breaking changes, it will allow you to have a better chance to have a good domain right the first time, and to avoid having to implement API versioning or breaking changes. So really do event stormings. They work really well. The idea is to have, for those who don't know about it, you put a tech expert and a domain expert in the same room. You have them talk, and magic happens. Third key point is simplicity. So endpoints and entities need to be very simple to apprehend. You shouldn't have to talk to a human to call the API. And so we built a checklist through some of Stripe's guidelines, which we've enriched with other aspects. So using fields in English, avoiding acronyms in any field. Even though they feel obvious to you, they probably won't feel obvious to someone arriving in 3 years in your organization. Use consistent date formats. Usually you need to have at least one date format for birth dates and one date format for date times and timestamps, so use the same. When you provide amounts, always provide the units, because you never know when your business will scale to countries with other currencies or stuff like that, so it's good to plan that from day one. Reflects mutations in responses. For instance, when you have a post, a patch, or a put endpoint, please do send the modified object in the response so that the client knows that the mutation actually worked. Then you have nested structures. So just to illustrate that, it's better when you have a sub-object to provide it in a nested structure rather than flatten it out. And the reason is that, for instance, if you have typing on the client side, you can have better types, because you'll be able, for instance, to create a payment type that is used inside the main response type. Use enum over booleans. So this is something that surprised a lot of my teams, but I always avoid using booleans in API responses. And the reason is that sometimes a third situation will arise. And a boolean is just basically an enum with only two states identified at the moment where it's created. So it's better to always plan an enum, even if it only has two different types at the beginning, because when you add a third one, it will be much easier for clients to migrate without a breaking change. Then you have polymorphism. The idea is that sometimes the API response sends subtypes of an object. And it's good to have a structure where you provide the type, and then you provide an object which repeats the type value, so that you can fetch very specific fields to this sub-object. And the idea is it's a bit the same as nested structure. This will allow the client to have a mechanism that parses the type, and then if you use object-oriented programming, you can directly, using a factory, implement the variant of the object that you have. So your JSON response is linked to object-oriented programming, which makes it easier. Use consistent resources over verbs policy. I've seen companies that strictly want to use resources and only use the HTTP verb to make a meaning. So for instance, if you want to cancel an appointment, they would use appointment cancellation and do a post on it, for instance. You only have resources. Other companies, and that's the case of Stripe, are allowed to use verbs in the URL. And my only advice would be to be consistent in that approach. So if you pick one, document it, provide this as a guideline to your teams. This is even something that you can do in Linter, especially with probably Gen AI allows you to do that easier now. And finally, provide clear description of fields. So usually the bad smell is when you have the name of the variable and you've moved from a camel case to space-separated words. It's usually not enough, so it's very important to really describe what you've discovered, for instance, in the event stormings, and to have that present in the description of the fields. Two final key points for APIs. Practicality. So do invest, especially if your company is focused on API as their product. Do invest in tools for developers to use. I'm talking about Postman collections, obviously open API contracts, and SDKs in the languages that are more practiced in the field. For instance, if you're a company which provide APIs for e-commerce, it's probably a good idea to do a PHP SDK. If you're in a different space, for instance, banking, Java is probably a better option. So do invest in the right SDKs to make the consumption of the APIs easier. And finally, defensiveness, because you all know Murphy's Law. So, APIs don't always work in the way you expect, so please do document stuff like rate limiting, error responses, put as much care in the unforeseen events as you did in the normal scenarios, because those happen way more often than you believe, and you won't get swamped with support calls if you document it well and the client can figure out something is wrong on its side, for instance. Also provide good tooling for observability, because when things go wrong, it's very good in your company to have the right stack to figure out what went wrong when an API call fails. So this is for APIs. If I now talk about events, so you have event migration, which is an issue. You have observability, which I mentioned, which is harder with events. And then you have the big question, in which case should I use events and in which case should I use APIs, because an event always approach is not sufficient. So for event schema migration, the important thing is to invest on making migrations easy for producers and for consumers. And for producers, there are several ways to do that. Let's say you want to change the version of a message. We found that the best ways to do so and to avoid breaking changes is to use the adapter pattern. So the very simple idea is that the producer will start broadcasting the message with the new format on a different topic or a different queue. And you have a component whose job is to fetch the new format and to transform it to the former format. And this allows you to have to really think about the edge cases that the consumers will face instead of pushing this question to them. And you can then migrate progressively the consumer components to the new version of the topics at their own rhythm, which is, for me, the safest way to approach this issue. And for consumers, one of the big challenges I've seen is that usually event registries are not as well documented as open API registries. And Backstage provides a way to, from Spotify, provides a way to see events through what is called async APIs. So for those of you who don't know about it, async APIs allows you to have the same spirit as open API, but for events. And so if you want to have your clients migrate, it's important for them to be able to switch between API and events in the same tooling. For observability, my biggest tip would be to make correlation IDs universal. So correlation IDs are something that you put usually in a header, and for you to understand what went through from a final user request all the way through the architecture. So you want to follow the request all through your information system. And usually you have correlation IDs in API controllers, but you also need to think about other entry points of your application. So for instance, batch jobs. This is Spring Batch, so you need to have a correlation ID because this starts a request. You also need to have this in Kafka listeners. For instance, if you use event-driven, you should also use a correlation ID. And Hibernate listeners, because sometimes requests will be triggered from the persistence of an entity. And so I really advise to have the same correlation IDs for all those different entry points so that you can follow requests all through a stack that may involve APIs or events. And finally, when should we use APIs? When should we use events? So I had a trouble answering this question, so I went around my teams, and what they said to me, one said that the architecture, this is what I said before, his project, the CTO wanted to use events all the time, so I knew I needed to find a way to combine both approaches. Another one said that usually teams are more well-trained in publishing and consuming APIs than events, so this made the cost of a feature based on events harder, so I understood that we needed to make event subscription and publication easier for teams to use them. And finally, I found out from this feedback from one who had to basically attach to any entity post, persist, update, and deletion events to any object on his IT, and he was very pissed off because it took him a lot of time to do very repetitive stuff, which was to add in Hibernate listeners post, update, and deletion events. So the approach we end up is what I call API first, event always. So you design your information system through APIs, which you've discovered through domain-driven design aggregates. You try to design your APIs in a way that they make sense for their business value and not just the very short-term decision that you have for your feature, user story. But then you make your entities publish events just in case. So that's why I call it API first, event always, because basically you never know when someone might need to enact upon something that happened in your microservice. And so we've invested in that. We've done an open source library, which we've released 1 month ago, which is called Spring Data Events. And this basically allows you to just put an annotation on a Spring entity. And anytime the entity is persisted, updated, or deleted, this forwards an event to Kafka and possibly other queuing solutions that we'll pick in the future. And so this is called change data capture, and there are tools that do that, such as Debezium, but I wanted to make something very simple for teams who use Spring Boot without needing them to spawn a new technology or stuff like that. So if you have some feedback on it and want to contribute, we'd be very happy to have your contributions. So to finish, the key takeaways: focus on quality through domain-driven design and event storming, and this is true for API and event-based approach. Invest in the tech asset that you have. If you want to make event-driven architecture work, you need to know that there's an entry cost to make it work. And finally, if you agree, think API first, event always. Thanks a lot.
Thank you very much, Woody. Do we have any questions? Because I don't see any in Slido. Oh, now they appear. Interesting. OK, how much data do you put in the events, the whole entity or a summary?
So usually what I do for this is that I only put data that is in the entity. I don't put data that is through linked entities, such as one-to-one or one-to-many. So I'll put obviously the ID and the simple fields, the primitive fields that you have in the entity. And for other fields, I encourage the consumer to grab the data, the missing data, through APIs. This avoids having event bloating, where you, anytime a consumer asks for extra data, you just put it in the event and you end up with a lot of problems because the event doesn't make sense at some point.
Thank you. Don't you get a lot of unused events in Kafka like this?
So I don't. Spring Data Event doesn't apply this behavior to all entities. I get to pick which entities on which I want to put the annotation so that I don't end up having unused events everywhere. I just wanted to make it very simple, one line of code for the developer who wanted to do this operation because of the feedback that Antoine, who was the third picture, gave to me, that he spent a lot of time adding this by hand on each entity.
Thank you. What do you think about CRUD versus domain events?
I'm not sure I understand the question well.
What do you think about CRUD versus domain events? Yeah. Who wrote the question? Would you care to explain? Yep. I'm coming to you.
So you could think of events in like create or update, or in terms of your business case, like, I don't know, sales order confirmed or something like that.
Well, the library we made was really aiming at solving the CRUD use cases, which sometimes happens. You want to have a reaction upon the persistence, the update or deletion of an event. But obviously, I want to still be able to broadcast specific events that are not CRUD in my Spring Boot app. So the library aims at only solving the first one. And yeah. I don't know if it answers the question, but
Yeah. Okay. Thank you. What do you prefer for change data capture? From the code, example, your library versus external like Debezium,
yeah.
pros and cons.
Well, I think for simple use cases, especially when you have teams that are not really well trained on events, it brings extra complexity, obviously, to add a new tech library such as Debezium. But obviously, at the moment, Debezium is way more powerful than the library we just created. So if you have really business use cases that rely a lot on change data capture, I would advise using Debezium, which allows you to do a lot more resilient, which does this in a more resilient way and has more features than what we've built. This is very simple for teams who want to get started with events and just need to broadcast crude events. This is all it does at the moment. I hope it will evolve, but it's all it does right now.
Thank you. Different events for all object field changes or one event for multiple field changes?
So we've designed this so that it's really linked to hibernate events. So when a transaction finishes, it will broadcast post-persist or post-update any change that was done of the entity. So you won't have several change, one event per change. You will have the reflection of the entity modification in the database through events.
All right. How does this solution preserve the values of event-driven architecture like scalability and loose coupling? For any update, you need an API.
So it doesn't really change things for me around these benefits, because I think that when you have, let's take the two separately, when you have scalability needs, I think that you should use events in that case and not rely too much on API, especially if you have heterogeneous loads on your application. So you should try and figure out in the use case that you have whether or not those benefits should those benefits justify using events or APIs. So this just allows you to have some sort of an automatic way to broadcast events, so the event first approach, the event always approach, but you should choose one approach or the other if one of the benefits I mentioned before makes more sense in that business case.
Woody, thank you very much, or should I say merci beaucoup?
Thank you.
Let's give him a round of applause.